Chapter 7, Lecture 3 is going to talk about freshwater systems, which, of course, living in our area, we are much more familiar with. Freshwater systems by nature contain less than 1% by volume of salt. Keep being in mind that marine systems have about 3% or greater. Two types of freshwater systems, either standing or flowing. Standing means they're not going very far. That is like a lake, a pond, an inland wetland. That is called the lentic system. The problem with lentic systems is if there's pollutants in there, they tend not to flush out very easily as compared to a lotic system or flowing system. Streams and rivers, the Fox River, for example, is a lotic system. If pollutants are dumped into there, not good, obviously, it's going to kill a lot of creatures, but it will be flushed out much quicker. Kind of interesting idea around here is there are some lakes that actually have rivers kind of flowing through them, so they're both technically a lentic and lotic. Formation of lakes, so how do they form around here? All the Great Lakes, and the other lakes around here, the smaller ones, were actually formed by glacial activity when they retreated about 30,000 years ago. Tectonic activity can actually split the earth and form lakes. Volcanic activity, oftentimes if you go to regions like Hawaii or the tropical regions where they have big volcanoes that exploded and then those caverns actually fill in with water. And of course some can be human-made. 4 zones that are based on depth compared to the ocean zones. Remember we talked about coastal zones and bathyl and euphotic and abyss. Well, a little bit different for fresh lake systems. It'd be really nice if it was the same, but it's not. Anyway, near the shoreline is what's called a littoral system. So kind of where most of the plant material is going to be. If you ever see things like cattails growing or grasses, it's going to be in the littoral. They're submergent, in other words, underneath the water. Plants, there's emergent that come through. There's enough light, basically, that can penetrate, and photosynthesis can occur. There's limnetic systems. Limnetic is further out in the open. That's where if you're a fisher person, you might probably go out in the middle of the lake and fish, or swim for that matter. Open, there's sunlight, surface away from the shore. That's the most productive for food and dissolved oxygen, mainly because that's where there's going to be a lot of phytoplankton that's going to be located there. The profundal zone, which is below the limnetic zone right here. Aphotic, that means that light is not able to penetrate very well. It's deeper, open water, too dark for photosynthesis. We have low dissolved oxygen here because photosynthesis does not occur. Around here, lakes vary. Some are very crystal clear, some are dirty. The dirty ones, obviously, that profundal zone is going to be a little bit higher up near the surface. Benthic, of course, is the bottom. We tend to get low temperatures, low dissolved oxygen there. This is where mainly around here where decomposers and detritus feeders are going to exist. Stratification is a unique property that happens with freshwater lakes. Stratification is layers. If you take a look at the picture on the top, we have what's called an epilimnion, a thermocline, and a hypolimnion, kind of outlined on the bottom here too. What that is are the different layers that exist, the stratification. The epi is kind of like epidermis, your top layer of skin. The hypo, think about a hypodermic needle. That needle goes below your epidermis. What happens is we get layers. So in the summertime, when you jump off a boat into the water, it's going to be really warm at the top of the epilimnion. Then you're going to hit what's called a thermocline. A thermocline is kind of a transition area between the epilimnion and hypolimnion. The hypolimnion tends to be very cold. Stratification also occurs in the wintertime. So stratification, in the summertime and during the wintertime. Right now, of course, what we're looking at with winter is right below the ice, and the ice acts as an excellent insulator as we get 2 to 3 degrees Celsius, so just above freezing. But most of the lake is going to be 4 degrees Celsius. It's very good that we have ice on the lakes because they act as insulators and keep the water warm. Otherwise, if it was below freezing, of course, the fish would freeze and die every year. So it occurs in temperate lakes. During the fall and spring, we get a unique thing called turnover. This is pretty much exactly the same as upwelling that occurs in the oceans. What happens is it brings nutrients up, reoxygenates the bottom, and evens out temperatures. So what happens is in the spring we get winds that occur. They're going to cool, they're going to descend, and they're going to create these convection currents. Same thing in the fall. So again, we get those nutrients and oxygen that come back up, and fish are going to follow that. turnover. A couple different types of lakes, and we have examples of these around here. First one is something called an oligotrophic lake, which is the picture on the top right here. Low levels of nutrients and low NPP, very cold, very high dissolved oxygen. They tend to be a little bit, they tend to be regions like Devil's Lake has one. Not a lot of these around. Northern Wisconsin has some of these too. Not around a lot around here, simply because we have so many phosphates and nitrates going into the water. But what happens is they can support game fish like trout. These tend to be pretty deep too, and a lot of those are carved by glaciers around here. Eutrophic lakes have very high levels of nutrients and high NPP. That's a picture of this one right here, and you've all probably seen those eutrophic lakes like this. And the reason they're called eutrophic is they go through eutrophication, which I'll talk about soon. Very high levels of nutrients. These are lakes where a lot of phosphates and nitrates have washed off into from most likely farmers' fields. They tend to be very shallow and murky. The reason they tend to be very murky, muddy kind of bottom is because as this plant growth is going to die, what happens is it goes down to the bottom, decomposes, and forms that mucky kind of layer. So these are the kind of lakes where you walk into and you kind of sink it in the mud. In between lakes are called mesotrophic, meso meaning middle. So what happens is we can get this thing called cultural eutrophication, which leads to hyper-eutrophic lakes, which is like this one right here, which actually could kill the lake, kill all the fish species off. Cultural eutrophication, the reason it's called cultural is because we as a culture put those fertilizers into the water. So just another way of looking at oligotrophic versus eutrophic lake. Oligotrophic lake is the top one. Generally very crystal clear around here. Beaver Lake is a good example of that. Neshota lakes are very much like this too. Tend to be a little bit deeper, but tend to be very clean because the nutrients aren't rushing off into there. They tend to be pretty new also. And the eutrophic lake, you can see on the bottom, very high concentration of nutrients and plankton. A lot of fish population because quite honestly there's a lot of food, but we can get a fish because of the eutrophication. Here are the steps of cultural eutrophication you need to know. First of all, nutrient input. What happens is we put a lot of fertilizers and onto our grass and onto our farmers' fields, and of course all that excess stuff that plants don't use because we put it on so heavy goes into the lakes. So nutrient input right there. Because of those nutrients, algal bloom. We have a lot of protists that love it. They thrive and they grow very well. Then what happens is we run out of nutrients. So we run out of nutrients, that algal bloom, they're going to stop reproducing, and we get algal die-off. Now when that plant starts, or those photosynthesizing protists start dying, what happens is naturally bacteria will come along and decompose them. The bacteria that decomposes them are called aerobic. Aerobic meaning they use oxygen to decompose, and then what happens is we tend to get decreased dissolved oxygen. Now if we have decreased dissolved oxygen, what happens? Our fish are going to suffocate and die. Then to take this even a step further, what happens like on Pewaukee Lake is the fish start dying, and then their bodies, their corpses obviously float up, they come ashore, and then anaerobic, which does not require oxygen, bacteria comes along and oftentimes emits things like methane, which is why it smells really bad. Freshwater streams and rivers, so where do things come from, particularly surface waters? We're not quite talking groundwater yet. The picture on the right side is what's known as the Milwaukee River watershed. So what happens is all of these lakes around here, if you go all the way through here, eventually are going to go through into the Milwaukee River and into the Great Lakes, into Lake Michigan. So if you go up into Germantown, any pollutant put in up in Germantown is going to go into the system. Mequon, West Allis, New Berlin, Elm Grove is in the system. Half of Brookfield is in the system too. The half that's actually east of Calhoun. Surface water receives most of their recharge from runoff, snow and rain. Obviously, if we have a lot of snow in the winter, what happens is that's going to melt and that's going to run off eventually. That runoff, of course, is going to include any sediment and dissolved leachate, even things like if you see the oil spills, like cars leak oil, of course, out in our parking lot, what happens is that oil is going to get washed off too and get into these systems too. We get, that whole area is called a watershed or a drainage basin. That land area provides runoff for rivers or streams, and again, all those pollutants that are in that system are going to go. Another way of looking at that this is kind of, if you think about Arizona, Nevada, California, a lot of their water actually comes from the mountains, so they get snow caps on the top of their mountains, and what happens is when it melts, the melting occurs in what's called the source zone, which is the source zone on the top. Very steep waterways. Again, if you go even out east and into the Appalachians or into the Rockies, this is really turbulent. If you're a trout fisher person, you probably want to go there because the water's very cold and it's got very high dissolved oxygen. Then we get something called the transition zone, where these streams start to meander and slow down a little bit. Eventually we get a floodplain. People love to live in floodplains. Milwaukee is a 100-year floodplain, which I can't. So what happens, the source zone, as I said, what happens is the system directly fed generally by snowmelt. Of course, it could be rain too. This could occur in tropical regions also. We get very narrow and fast-moving river systems up there. They dissolve large amounts of oxygen from the air and plants. Even as the waves come up and capture oxygen in the air, it'll actually carry it down into the water and, of course, cause dissolved oxygen. A lot of trout fishing occurs in areas like that because trout like high dissolved oxygen content. Then we get a transition zone, wider, deeper streams with gentler slopes. Water starts to warm, we get more nutrients, we get some producers here because the water's slowing down, plants can kind of hold on a little bit easier. We do get a little bit lower dissolved oxygen because the water warms up a little bit and that oxygen dissolves right out. Then we get something called a floodplain zone, which tends to be very flat. We love living in floodplain zones because they're flat, we can build on them easy. They tend to be very fertile too because all the silt came from all different areas like in the mountains and came down with all the nutrients. Wider, deeper rivers, they tend to be meandering. If you think about the Fox River system, if you looked at a map, the meandering system kind of looks like this. Water temperature is warmer. It's because it's slower. It can absorb the water. We have less dissolved oxygen because of that. The flow is slower. Large number of producers, algae, rooted plants, because, again, it's moving slower and they can actually hold on. And we tend to get very fertile soil, so we tend to farm these. Milwaukee is actually on a 100-year floodplain, which means every 100 years it's expected to flood. Freshwater inland wetlands, very important. Marshes and swamps sink along the Fox River system. Kind of like the picture shows right there. These are critical. Wetlands are very protected in the United States, not other parts of the world. Prior to the 1970s, when these things really started getting protected, we drained these things because they were along river systems. We like to live along the river or along the ocean for that matter. And what happens is it causes really bad damage to our ecosystem. So marshes are dominated by grasses, swamps are dominated with trees. Along the Fox River, it's actually a marsh. Prairie potholes, what that is, if you ever go to Minnesota, and of course they're claimed to 10,000 lakes, which is probably true, a lot of those are prairie potholes. Those were actually carved by the glaciers at one time, and they're really small little lakes, kind of the size like of a classroom, but of course they count in this. Floodplains are examples of these wetlands. Bogs, which are very similar to the swamps, of course, but these play a role. We need freshwater wetlands, again, like along the Fox River. What they do, they're natural recharge the groundwater system. They're a low-lying area in Brookfield. When it rains, stuff is going to go along the Fox River naturally, unless we've impeded that. Very great habitat because there's high NPP. Nursery for aquatic species for spawning fish is excellent there. Filter and degrade toxic waste. Reduce flooding and erosion. So if we mess with wetlands, if we ever took those out of Brookfield, Brookfield would flood a lot more often. These actually absorb it. Any toxins put in the environment, a lot of them go to that wetland and it actually naturally absorbs them, so they're very important part of our system. Habitat loss, we'll talk about a little bit more when we get down to things like extinct species and endangered species, but it's really the largest impact on biodiversity. Again, if we destroy those wetlands, which has high NPP, we're actually going to take away the home for a lot of creatures. A lot of times we do destroy them to make room for urbanization, agriculture, because they're very fertile areas. Coastal areas are devastated for fishing practices, urban development, so we tend to raise fish purposely, and they're in a process called aquaculture. Floods do control levees that alter and destroy habitat, flood control rather, levees like along the Mississippi River and New Orleans, it's all controlled by levees. Really shouldn't have those levee there, we should let it just kind of flood out. In other words, New Orleans really shouldn't be there. It's a great place, obviously, but it's 3 feet below sea level. It's not a natural thing. We're controlling that. Cities and farmlands do add pollutants to these areas too, unfortunately, and does cause cultural eutrophication to things like wetlands. And unfortunately, the U.S. has lost about 50% of our wetlands since the 1600s, which is a terrible thing. We're trying to reverse that effect right now. That's it for Chapter 7.